All cell phones, electronics should be away. And it says, let's talk about quotient of power. So we are dividing. Quotient is the name for the answer to a division problem. You can use repeated multiplication. So if we have 2 to the 8th divided by 2 to the 3rd, we could write it all out, but that's long and tedious. And we would see that the 3 on top and the 3 on the bottom cancel out, and we are left with 5 2's that are being multiplied together. Okay? Or we know that if you are dividing two powers that have the same base, that we can subtract their exponents and make that 2 to the 5th power. Okay? Same as r to the 5th divided by r to the 4th. Let's use this one. Here's what she has. Who is this from Miss Martin? Okay. The thing, I think I have them. I just haven't had a chance to look at some of them. And I'm right in the middle of teaching right now. So I can't do it right now. I can take a picture of it and maybe get them to you by tomorrow. Come on in. Okay. This is 11:50. I can't do it right now. Okay. Sorry. Okay. So we do the same with r to the 5th divided by r to the 4th. We have that same base of r. Since we are dividing, we are going to subtract and get r to the 1st power, which you can also just put as r. Okay? So to divide two powers with the same base, subtract the exponents. Subtract. Keep the base and subtract the exponents. So let's go down to the examples. I think this is at the top of your next page, maybe. Maybe not. Example 1, quotient of powers. So simplify b to the 5th, c to the 7th, divided by b to the 2nd, c. First of all, make sure you have an exponent on all of these. So I do not have anything on this c in the denominator. Put a 1 on it. Okay? And then we are dividing. So we're looking at b to the 5th divided by b to the 2nd. Those are being divided, so keep the b. And 5 minus 2, I do that vertically and put just a little subtraction sign in there. And that is b to the 3rd. Then you also have c to the 7th divided by c to the 1st. Put a little subtraction sign in there. And I showed this vertically. That is c to the 7 minus 1 is c to the 6th. Question. Why can't I add these together and say BC to the 9th? Why can't I do that? Are they the same base? No, so you have to keep those separate, okay? They have to be the same base when you are multiplying powers or when you're dividing powers, all right? So let's take a look at some more of these examples. A to the 2nd, B to the 9th, C, D to the 4th. Let's put a 1 on our C up here, and let's put a 1 on the C in the denominator. Okay? So first up, we're looking at A. I don't have any other A, so you're just going to keep A squared as it is. All right? Then I have a B to the 9th being divided by B to the 8th. I know I'm going to subtract, so I put that little subtraction in and show it vertically. That's going to be B to the 1st power. And then I've got C to the 1st divided by C to the 1st. What's going to happen there? What's going to happen here? C to the 1st divided by C to the 1st. Yeah, they're going to simplify out. Now, we can say cancel, but when you have a number divided by itself, it simplifies out to be just 1, right? It's not like we're adding or subtracting. So this is a 1 that's being multiplied on the other sides. Okay, so they simplify out. And finally, I have D to the 4th divided by D to the 3rd. Put a little subtraction sign in there. And that's going to be D to the 4 minus 3, which is D to the 1st. Do I need to keep these firsts on there for the exponents? No, you don't need to. You can, or you can rewrite it A squared times B times D. Either one is okay. I would say this second one is probably better, but I would not take off. I would not take off if you left the 1 on. Okay? Any questions on that? All right, let's go to B. Ooh, this would have been a good one maybe to do before we had the test. Some of you and your fractions. Ooh. What is 2 divided by 8? Is it 4? No, but a lot of people were trying to tell me that it was. Put that away, please. So 2 divided by 8. You have to simplify and see what number goes into both of them. What number does divide into both of them? 2. So when you divide by 2, you're going to get 1. And when you divide 8 divided by 2, you're going to get 4. So you have just simplified 2 over 8 to be 1 over 4. Then we have x to the 4th divided by x to the 9th. Put a little subtraction sign because you are dividing, so you subtract the exponents. And that's going to be x to the, what is 4 minus 9? Negative 5. And you're like, oh, wait, we can't have a negative. We'll deal with that at the end. Okay? Then we have a y to the 3rd. But we don't have a y on the bottom, so we're just going to leave that as y to the 3rd. And then finally, we have z to the 5th divided by z to the 8th. Subtract the exponents, and that is going to be z to the negative 3. Now, you have done a lot of good work up until this point, but that is not in simplest form, okay? We just said when we have these negative exponents, they don't like being in the bunk they're in. You know how it is. If everybody's in the top bunk, they want to be on the bottom. If somebody's in the bottom bunk, they want to be on the top. So let's write this out. First of all, we have 1 over 4. We have x to the negative fifth. Right now, that is in the top bunk or the bottom, would you say? Right now, is x to the negative fifth in the top bunk or in the bottom? It's in the top. So we need to move this down and make it x to the fifth power. Okay? Then we have y to the third. All right, so y to the third, that's just a regular 3. That's going to stay where it is. And finally, z to the third, negative third. It doesn't like being in the top part, so it goes down to the bottom and becomes z to the positive third. If I simplify it, I don't need the y or the 1 out in front, although I could leave it. Final answer would be y to the third, all divided by 4 x to the fifth, z to the third. But again, if you put the y and leave it there, that's okay too. Okay. All right. Any questions on that particular problem? Let's see about getting you guys to do some. See what you can do with letter C. It's kind of an interesting one. Letter C. Letter C. What do you notice about this letter C? There is a negative out front. Very good. That's good to notice. So that negative I would probably put with the first number and make it maybe negative 3 over 1 for now. Okay. Yeah, what else do you notice about this problem? What, if anything? Okay. Let's see what he says. Say it a little bit louder. 3 minus 2 with the J. Okay. Well, what about H? Because I usually like to go in order. Somebody talk to me about H. H to the fourth divided by H to the fourth. Okay, let's try to say simplify because, yes, they will simplify out and just be the number 1. Okay, or maybe I put it up there. All right, so now I have J to the third divided by J squared. Like he said, they have the same base. Put a subtraction sign in between. So that is J to the first. And finally, K to the third divided by K to the third. Paula, what's going to happen there? K to the third divided by K to the third. Okay, simplify out, and that will just change to be 1 also. So I have negative 3 over 1 times J over 1, or J to the first, times 1. So if I simplify this, you know, the 1's don't really do anything. I just have negative 3 times J. And I don't need that 1 to be the exponent, but I could leave it there. But this is probably the best simplified answer. Okay. Let's go to letter D. Letter D. Notice we have a negative sign out front. 4 over 4. That's going to simplify out to just be 1. I have x to the third divided by x squared. They're not lining up quite as well, so I might actually rewrite that as x to the 3 minus 2. So I know I've taken care of my x's. I've got y to the third minus, oh, I forgot to put a 1 on it. So that's y to the 3 minus 1. And then finally I have z squared. So after I simplify this, I have negative x to the first, y squared, z squared. And again, I don't need to have that 1 there. Negative x, y squared, z squared. Any questions on this? Can I see your inside sheet real quick? Six through 8. We are on page 7. Okay. Let's see if we can push a little bit further. Power of a quotient. Powers of a quotient. Okay. So this time you're going to have the 3 as your exponent. Let's go to example 3. Way down at the bottom. And again, everything is going to get multiplied by 3, even if it's in the denominator. Okay? So first of all, if you don't see an exponent, put a 1 on it. So the 5 is 5 to the first. A squared divided by 6 to the first power. All right? This 3 on the outside gets multiplied by every exponent, even the one in the denominator. So this becomes 5 to the 1 times 3, okay, times a to the 2 times 3, all divided by 6 to the 1 times 3. Okay, so we need to simplify and say 5 to the 3rd, a to the 6th, all divided by 6 to the 3rd. Now we want to simplify this because we know that 5 to the 3rd is some larger number. What is 5 to the 3rd power? 5 times 5 times 5. What is 5 times 5 times 5? 125. A to the 6, you can't simplify that. All divided by 6 to the 3rd power, take 6, that caret, and 3, and tell me what you get. Anybody? What's 36 times 6? What is it? 5. It's got to be higher than that. 6 caret 3? 36 times 6. What is it? 162? Is that right? Somebody take 6 caret 3. 216. You take 6, the caret button, and then 3 should be 216. So this is your final answer. Okay? All right. And turn to the next page. Let's see if we can do this top one and we'll call it a day because we're running out of time. All right, so we have many things that are written and the whole thing is taken to the 4th power. First of all, if you see something without an exponent, put a 1 on it. So the 5, I'm going to put a 1 on it. The J has a 3, the L has a 2, 7 on the bottom, I'm going to put a 1 on it. And that whole power is 2 and taken to the 4th power. So that means I am doing 5 to the 1 times 4, j to the 3 times 4, L to the 2 times 4, all divided by 7 to the 1 times 4, and K to the 5 times 4. So this is the top of page 9. So simplifying it, I'm going to say this is 5 to the 4th, J to the 12th, because we're multiplying, L to the 8th, all divided by 7 to the 4th, and K to the 20th. Now again, you cannot simplify a variable raised to a power. There are 2 things up here I can simplify. 5 to the 4th is 5 times 5, which is 25. Times 5 is 125, times another 25 is 625. J to the 12th, L to the 8th, divided by, and 7 to the 4th is 7 times 7, which is 49. And 49 times 49, I have no idea. You got me? 7 to the 4th power. You have a number? 2401. 2401 times K to the 20th. And I am hoping that that does not simplify. 625 over 2401. I don't think it does. All right. Stick a fork in me. I am done. So, homework though, and this is where it needs to be said. Homework number 1 is due tomorrow. Okay? While I want you to understand and make sure you know how to do the problems, I also want you to try those problems, okay? I think part of the problem is we're not getting the homework turned in close to the date when it's actually due. If you turn it in the day before the test, I don't really have time to grade it and get it back to you to show you what you don't understand, okay? So please, try to get this done and turned in for tomorrow. Come with your questions. Okay? Come with questions. And I do have some people coming in working on corrections. And if you have a question, you're already in here. Just ask. Okay? Just ask. So homework number 1, due tomorrow. Also, don't forget, we have that weekly Canvas activity. We started that up again earlier this week. So 9/22 should be due tomorrow.